All right, I'm going to run through some solutions to the staircase. So we're going to say that this is n equals 1, figure 1, n equals 2, n equals 3, n equals 4. The first, probably more common solution that students will come up with is a recursive formula. So if we let f sub n, equal the number of tiles in figure n, so the total number of tiles, then what I think a lot of students will do is they will say, to find the figure you want, you could take the 1 before it and then add in n. And so if you look at this, here's the 1 before it, and then you add on 2. Here's F2, right? And then you add on 3, which is n. Here's F3, so n minus 1, and then you add on n, which is 4. So in each case, you take the figure before it, and then you just add on n. So that's the one that's probably the most common to start. All right, now we're going to have some fun with geometric solutions for explicit formulas. So explicit formulas meaning you don't have to get the ones before it to get the current one. Recursive formulas are going to take a lot. If you want to go up to high figures, you'd have to figure out the 99th one, for example, to get to the 100th one. So explicit formulas are a lot more helpful in getting the higher number of staircases. So one way you can think about this is to get a figure, you can think about recreating this staircase and kind of stacking it Tetris style on top of itself. So here, I'm going to recreate it and stack it on top of itself. And then here, ugh, my drawing's terrible. I'm going to recreate it and stack it on top of itself. I need another block to do that. There we go. And then here, same thing. So I'm kind of like doubling what it looked like. Just making a copy and then stacking it on top of itself. And we can do it for the first one also. Okay, so now if you look at these, we've made rectangles and we know the formula for finding the area of rectangles, so finding the number of squares based on a rectangle. So if you look at all of these, the base of the rectangle, the bottoms, for example, are going to be n. Okay, so n. And the area of a rectangle is length times width. So if you want to, it doesn't matter which one, call that length, then we need the width, or width and we need the length. And so now if we're looking at this side of the rectangles, oops, my brackets are terrible. They're always 1 greater than the number figure. So this is n, and then the other dimension is n plus 1. And we're trying to get the number of blue tiles. So it's half, right? Because we duplicated the figure and then stacked it on top of each other. So the number of blue tiles is that full rectangle cut in half. And so n times n plus 1, all divided by 2, will give you the number of blue tiles. Okay, so this next one comes from viewing these as triangles instead of doubling rectangles. And so what I'm going to do is I'm going to imagine that these are all nice triangles without jagged edges. So I'll just make it so. So I'm cutting off all the jagged edges and just making them look like nice triangles. Okay, and so for each of these triangles, we can find the area using half base times height. So half, the base in each of these instances is n, 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 n. And then the height is also n here. Okay, so we have half base times height, but then we have these extra little half pieces. So if we think about how many little half pieces we have because we need to add those in because we want all the blue tiles. We have the same number as the figure number. So this has 1 half piece, 2 half pieces, 3 half pieces, 4 half pieces. So it's adding on half of n to get those half pieces, and that'll tell you the total number of blue tiles. This one's a bit tricky, but I really like it. So the way you think about this one is, let's just use all the blocks to level it out and make nice rectangles. So for here, we're not going to be adding anything. We're just reconfiguring to make perfect rectangles. I'm going to chop this guy in half. So the first figure here, this guy, he's already a rectangle. He's a square, which is a rectangle. This one was not. So what I'm going to do is I'm going to chop it off, and then I'm going to take this piece here and move it there. Okay, so now we have a nice rectangle, and I'm going to do that for all the others. So you'll notice that every other one moves quite nicely in a full piece. And then what happens in some of these others, so I'm going to move this piece all the way down here. And then I'm going to chop off these and move them here and here. Okay, so I've made everything into rectangles using the blue tiles. So imagine they're all blue. So now I just need a formula to describe those new rectangles, and that'll give me how many tiles I used, the area of the blue. And so the base, if you look at the bases, are all n. So base times height is the area of a rectangle. So that's n. So now we have to figure out the height. So this was a little tricky, but the height of this is 1. The height of this one is 1.5. The height of this one is 2, and then 2.5. And if you think about those in relation to the figure numbers, so this is figure number 1, figure number 2, figure number 3, and figure number 4, there's actually a pattern there. So the way that I think about it is that I take one bigger than the figure number, so the next figure number, and I half it. So 1 is half of 2, this is half of 3, this is half of 4 for the next one, this is half of 5, 2.5 is half of 5. So it's n is the base, and the height is half of the next figure number. And that's another way to find the total number of blue tiles.